So hello guys, welcome back to another live session. So today is March 6th. So this is the today's problem they have given in the LeetCode, that is 1784. Check if binary string has at most one segment of one. So here's the challenge. I am going to show you a LeetCode problem that looks like it needs a loop. So careful counting and state tracking, and then I am going to show you that the entire solution from intuition to the code and collapses into a single observation and barely nearly 3 lines of C++. So that is LeetCode 1784. Check if binary string has at most one segment of ones. So it is a easy level of difficulty here, as you can see here, and but the elegance here is something else. So insignificant hides in plain sight, and once you see it you cannot unsee it. So let's begin. So here's the problem statement. What they have given is, they have given a binary string yes with without leading zeros, return true if yes contains at most one continuous segment of one, otherwise return false. So what they have given, so given a binary string with without leading zeros, they will give a string without any leading zeros, and we have to return true if the string contains at most one continuous segment of ones, otherwise we have to return false. Okay, so this is the statement they have given. So what is the segment of one? A segment of one is the maximal consecutive run of the one characters, the character one. So let's look one example and make this concrete. So I'll not open the notepad. So this is the string they have given, that is 1001. So let me take some more samples. So like 110 and 111 and 10. So after that 111 double zero. So it is a single one. So this is called, we can say it is a single segment. So single segment. So the next one is double one with zero. So double one is followed by zero. It is also one segment. So next problem. So the next problem, all of them are ones. So all of them are ones here. So as you can see, it is a single one segment. I'll remove this. So after that, here it is 10. So 1, after that then 0. So it is also one segment. So as you can see, 3 ones and 2 zeros. This is also one segment. So let us see with two segments or more. So if I take zeros 1 and like 101 and 10011, because we can't give 0 because they have mentioned that without leading 0. So we can't initially starts with 0. So after that 11 00 101 like this. So 1, after that some gap, after that another one. As I can say that it have two segments which is separated by 0. So it is also have two segments. It also have two segments. If you see here, so one separated by zeros, another one unseparated by 0. it have 3 segments. So this is how this segmentation is works. So they have said that if it contains at most one continuous segment of 1, we have to give 0, say true, or else we have to return false. So the critical constant is they have given no leading zeros. The problem guarantees two things, that is S of 0 is always 1, the first string, and there are no leading zeros, so this is just a minor detail. So let's see the two sample they have given here. So first they have given 1001. So if you take this string, the output they have given is false. So the one from two separate segments, and at the index 0 and 1 at the index 3, between them there is a gap, that is called two zeros here. So it have two segments, then it is false. Okay, so it is the two ones in between, there is a 0, it is separating these two ones, so it have two segments. Okay, like this 1 0 0 1. So this is the first segment and this is the second segment. So if the segment is greater than 1, that means it is false. So let us see for the next one. So that is 1 1 0. So this both ones are continuous, and this 0, after the 0 there is no 1 here, so it is a single state segment, that is one segment. So if I see one segment, I can say it is true. So let's see the code inside of this problem. So here's the key question. So when does the binary string have more than one segment of ones? So exactly when there is a 0 followed by 1 somewhere in the string, like this 0 followed by 1. If you see 0 followed by 1, so that time I can say that it is false. Okay. So why? Because, so think about it, if a 0 appears somewhere in the string, then 1 appears after it. So that means the 1 before the 0 is one segment, and after the 0 is another segment. So this is the two segments by definition. So if any pattern, for any pattern, if you take it like 1 triple 1 0 1 1 0 1 1 0 1. So as you can see, after the segmentation starts, there should be 0 1 0 1 and 0 1. So it is exists in the string, that is multiple segments here. So conservatively, if 0 1 does not appear in the string, then the ones, there are only one segment here. So the string will look like something that, for example, if I take like this, it should be like this. After the completion of 1, there's only zeros here. There will not be 1 after the 0. So without this guarantee, a string like 0 triple 1 would have. So one more thing they have said, it will not start like this. So there's no worry for that, because there is no leading 0. So we don't need to worry about these test cases, because there should not be any test cases like this. Since the first character is always 1, so the 0 1 found means that time we can simply say it is false. So that is the proof of two segments present in this string. So the entire problem reduces to, does the string contains the substring, that is 0 1 1 or not. So if the substring 0 1 is present, we will return false. If no, we will return true. So now let us write the program. So here they have give, first let us see the problem function they have given, that is boolean data type and the function name, and the parameter is the string they have given. So we have to give the boolean as the output. So we have, it can be either true or false. The input is string. So since we only read it, nothing modified, it's fine to take by the value. So for completeness, in the product set, production settings, you construct a string like constant string with the address. So but for LeetCode submission, so it doesn't matter. So first we can just write a for loop. For we'll iterate through the string. So in this string, I name it with the iterator as I, and I'll give the condition that is I plus 1 less than the size of the string, and I will be incremented by 1. So we may ask why I plus 1 instead of single I. So we have to check within a single for loop instead of nested for loop. So we loop from the index 0 and the second index will be I plus 1. So because inside the loop we access I string of I plus 1, that is the first character and the next character, we need to make sure that the index is valid. So if I were allowed to reach the last index, so the I plus 1 will reach the next box, that is out of the box. So writing I plus 1 less than the size is cleaner and safer, or else it is also safer than s dot size minus 1. So which has an unsigned of subtraction bug risk when it is empty. So now, because if I give size minus 1, if it is an empty string, there would be some bug. So that time I plus 1 less than size is safer. So after iterating through the string, I'll check that if my current character s of I is equals to 0 character and it is followed by, that is the next character is the character 1. So 0 and 1 is present in the string. So this is nothing but the condition 0 1 substring is present in the string. So at every adjacent pair of character we check if the pair is 0 then 1. So that is exactly 0 1 substring we are looking for. So both condition must be true together at 0 at the position and I at position I plus 1. So if it is, we'll that simply return false. So if it is get out of the loop, we just need to return true. So the moment we found 0 1 anywhere inside the string, we know that there is at least 2 segments. So we immediately return false. There is no need to scan further. So for the next thing, the return true. The entire loop is completes without finding the 0 1. The string has at most one segment of the 1. So we will return true. So we can alternately do one more thing. First let us run it and write the another thing. That is, so int I is 0, I less than 1 string dot size. So I plus plus here. So here is the closing braces here. So that is the error. So the test case is accepted. So we have one more solution that is shorter. So now I simply change this line. So here we can just return string dot find the substring 0 1. So if I find this within the program, so string in the position. So if I find in this position, so within the string I checking for the substring. So if I found, it will return true. If not found, it return false like that. So now let us check. So see here, the test case is being accepted. So I'd like to go through the previous method. So I don't want to use inbuilt method. So this method is easily understandable. So in the previous method I have written is which is constant, meaning that is not found. So if 0 1 doesn't appear, So if 0 1 is not found, we return true. If it is found, we return false. So it is in a one line version of equally valid. So is you can use whichever feels more reliable to you. So the string n position is the maximum value of string size. So that is effectively a sentimental meaning of not found. So it equals to some value on the 64-byte systems. So let's try run this program. So let us try run with this. My string, that is 1 0 0 1. It is expected to be false. So let us check it with our program. So initially the I is 0. Okay, initially the I is 0 and the S of 0 would be character 1. So what I am checking, so next is I plus 1, that is 0 plus 1. So string of 1 is, I'll use comma to separate these two, and 1 and 0. So as you can see that 1 0, this is 1 0, the substring would be 1 0. So 1 0 is not 0 1. Correct, we are checking for 0 after 1. So when you check this, you just skip it. So I will be move on to the next value. So I is 1. So S of 1, that is 0. So after that S of 2. So the S of 2 is again 0. So the next value is 0 0. So 0 0 is not 0 1. So it just simply skip one more time. So the next iteration, the I value is 2. So S of the string of 2, that is 0 1 2, that is 0, and S of 3, the last character. So the last character is 1. So if you add this both 0 and 1, it will become 0 and 1. So 0 and 1 is 0 and 1. So it is found. So when it is found, you can simply return false. So this is being found. After founding it, if 0 1 is found, we can just simply return false here. So we hit 0 1 at the index 2, so immediately return the false. So the correct is that it has 2 segments. So now let us check it. So yes, my string is 1 1 0. So this is the string. So in this string, my I value is 0. So after that, my S of 0 would be 1, and my S of 1 would be another 1. So 1 and 1 is not 0 1. So it we just need simply skip to the next iteration. The I value will become 1. So my string of 1 is, it is 1. So string of the next character, that is 2. So when you reach it, if you see this value is 0. So again if you see it, it is 1 0. So 1 0 is not 0 1. You skip it. So there is no more iteration, because if you check for the I values 2, so I plus 1 is 3. So what we have given, the size is also plus, the n is 3. So the condition is, if I plus 1, that is 3 less than 3, is false. It can't be same, it can't be less than, both values is equals value, so it can't be less than value. So that time the condition will become false. So finally it will return true here. So it will true here. So the output is true. So let us analyze the complexity of this program. So we scan the adjacent pair of this character exactly once. Okay. So we are scanning with the adjacent pair exactly once. So that time it is n minus 1 parsec. So we can simply say it is also big O of n. So the string that find version is also big O of n because it is internally loop from n up to 100. So this is essentially instant. So the time complexity is big O of n. So now I'll write here. So time complexity is big O of n. And for the space complexity, so see here, this is the space complexity. So within here, there is no extra data structures. We just use just a loop and a counter and a couple of character comparison. So it is in the constant space. So if you use in the find version also, it still use constant space. The constant space is big O of n. There is no extra spaces here. So the time complexity is big O of n. So now let us submit this problem and check it. So now it is being accepted. So now let us write your solution here. So the problem, that is LeetCode 1784. So LeetCode 1784 C++ problem with time complexity of big O of n. So in the time complexity is big O of n, and the space complexity is big O of 1. So you can describe your approach here, that is checking for the substring 0 1 in the binary state. So this is the approach and this is my code. So this is how your solution would look. So if you want some more content, you can ask any LLMs. So write a good looking approach and intuition, or make it to brief your solution, and you can post it. So now I'll just simply post it. So if anybody people wants to see our problem, they will just see it. So you can also upload like this. If you do that, your solution will go up to see in the other person's visuals. So now let us see what are the most peoples that will do the common mistakes in this. So what they would do is, many beginners write a loop that counts how many times the one is starts. So tracking a boolean in one segment that flips the states. So this work, but it's significantly more complex than needed. So the 0 1 observation eliminates all of that state tracking. So the mistake 2 is that they will off by 1 in the loop bound. So instead of writing I plus 1 less than size, they will simply write I less than size and passes an out of bound access. So the s plus 1, when it's in the last index, so this is undefined behavior in C++. So it may crash or silently corrupt your memory or produce some wrong output. So always be careful when accessing the next element. So, and forgetting why no leading zeros doesn't matter. So if you apply the same observation with the string with leading zeros, so let's take an example. So if I take instead of 110, 011, as you can see it is leading 0. So as you can see, so see here it is 001. So 011. So when it reaches this 01, so that time it will return false instead of true, because it is also called checking the 01 and it finds true. So that time it will return the false statement. So that's why it is very important that there is no leading zeros here. So the next one is checking for. Most of the people will check for 10 instead of 01. So 10 means the ending followed by a 0. It's that simple, right? So take 1, 2, 3 and flip it, you will get 3 to 1. So but here's the thing. So this problem has a hidden trap that catches beginners every time. So it is called integer overflow. And if you don't handle it correctly, your code will compile, run and silently produce a wrong error. So no error, no crash, that is wrong answer. So just wrong. So this LeetCode 7 reverse integer, it is a medium level of hard problem. So one of the most classic interview questions ever asked, and a masterclass in defensive programming and most working with numeric limits. So today we break it completely open. So the logic, the edge cases, and every line of the C++ solution. So a full dry run and the mistakes that have caused people interviews. So let's go. So given that they have given sign 32-bit integer and return x when its digits are reversed. So if reversing x causes the value go to outside the signed 32-digit signs, that can be minus 2 to power of 31 and 2 power 31 minus 1. So then return 0. So if reaches this value, we have to assume it and return the value 0. So they have mentioned that assume the environment does not allow you to store 64-bit integers, signed or unsigned. So this is the thing they have mentioned here. So now let us see for the example here. So it is simple here. So 1, 2, 3. You just need to give the output as 3 to 1. So for the next one, it is minus 1, 2, 3. And if you reverse it, you have to get minus 3 to 1. So these are the things. And for 120, so if you lead it, so the leading 0 will be removed in the integer, so it will become 21. So the trailing 0 is originally become leading zeros in the reverse number. So and the zeros are dropped. So 0 21 is just 21. So now let us see the overflow constraint. That is the real challenge in this problem. So here is why it gets interesting. So this is the 32-bit signed integer range. So for example, so integer minimum. So if you do that, the value is minus 2 147 483 648. It is in the negative value. So it is also known as 2 power 31. Okay, this is what they have given, that is minus 2 power 31. So this minus 2 power 31. So next is integer maximum value that it can store. So the same value, I simply paste it, but it have one lesser value, and that is 2 power 31 minus 1. So that's why we have 647 instead of 648. So this is the maximum and minimum value that an integer can store. So they are not symmetric. So the negative sides goes one further. So now what if that x is 1 0 0 0 0 0 power of 3. So for example, if I take any number like x is 1 triple 0 triple 0 and double 0 3. So if I reverse this, it will become 3 double 0 triple 0 triple 0 1. So as you can see here, this is the maximum limit. But here, as you can see, it is exceeding the limit. So that if it is exceeding this integer dot maximum value, okay, we have to return 0. So for example, if we take any other number like same number like this, but in the negative value, for example, y is negative this value, so it will convert into minus 3, and here it will become 1. So it is also exceeding the minimum range. So if if both conditions meets this condition, that is the special condition, we have to return 0 for both of them. Okay, so if it reaches here, we have to return 0. So no 64-bit integer constraint. So the problem says assume the environment cannot store 64-bit integers. So this is a deliberate restriction to stop you from just using long and checking at the end. So in practice, most C++ compilers do not support long, but the spirit of the program asks you to detect overflow before it happens. So using only 32-bit architecture. So we'll implement the cleaner version using this long for the safety, which still process on the LeetCode, and then discuss the pure 32-bit overflow detection approach. First, let us see the intuition and approach here. So first, how to extract the digits. So the core technique of reversing an integer without converting it to a string is extracting each digits one at a time from the right using the modulus and division. So for any integer, if we take any integer, so let me go down here. So if x modulus 10, if I use x modulus 10, so that time I'll get the last digit. Okay. So for example, if we take 1, 2, 3 and modulus 10, we'll get 3. So after that, for any number that is x divided by 10, it will remove last digit. So for example, 1, 2, 3 and divided by 10. So if you do that, you'll get 12. So we repeat this until the x becomes 0. Meanwhile, we build the reverse number by multiplying our result by 10 and adding each extracted digit. Okay. So how negative numbers behave? So in C++, the model operator on negative numbers preserves the sign. So the negative 1 modulus 3 divided by 10 is negative 3, and negative 123 divided by 10 will return minus 12. So this means the digit extraction loop works correctly on negative numbers automatically. So the digits come out negative, and when we add them to the reverse digit, so that's build up the negative number naturally. So no need for any special negativity flag. You just need to do this. So first, the overflow detection using the long. So we store the reverse number in a long variable, which is 64-bit on the most platforms. So this let us safely accumulate digits without overflowing. So after the loop, we check if the reverse number is less than this integer dot min and greater than this integer dot max. So if it is does that, we return 0. So let us write the code. So let us see here. So they have given that we have to return the integer as the output. So first we'll use long. I initialize with 0. Okay, so we use long instead of int to store the reversed number on a virtually all modern platforms. So long is 64 bits, giving us a math large range to automatically digit safely. So we use it int here. So multiplying reversed value by 10 and adding the digit could silently overflow before we even get a chance to check. So using long makes overflow deduction on a safe and explicit. So we initialize it to 0 before any iteration and no digits have been processed. So then I have to loop over it. So that is I am using while loop. So while the x is not becomes to 0, because when you divide it by 10, when it reaches the last digit, it will become 0. So we continue as long as the x has digits remaining. When x becomes 0, all digits have been extracted and added to the reversed. So for x equals 0 itself, the loop body never executes. We skip straight into overflow check. So the reverse equals 0 and return 0, so which is correct. So don't need to worry about the 0. So the next thing is we have to extract the last digit. So I'll declare one variable. So I'll name it as digit. After that, the number modulus 10. It will extract the last digit. So the modulus operator give the last digit of x. So the positive x. So this is always 0 through 9. So for negative in x, it is gives us negative 9 to 0. So the digit, even if it is negative digit, this will correctly get signed digit and our accumulation handles it naturally. So no need to worry about it. So after that we have to remove the last digit. So x star equals divide equals 10. So in integer division truncates towards 0 in C++. So for example, if x is 123 and if it is divided by 10, it will give 12. So for x is negative 123, it gives negative 12. So we remove the last digit and move to the next one. So this iteration of the loop process one digit and strings the x. So now we have to build the reverse numbers. So for that we have to store it here. So reverse digit is multiplied by 10 and add the last digit of the value. So now, so the digit is reversed operation. So we shift the existing reverse number one decimal place to the left and multiply by 10 and append the new digit on the right. So after loop finishes, the reverse will contains all digits of x in the reverse order. So for example, let us check here. So here digit, my digit is 3. So let me take x is 123. So first I'll extract the last digit. So the digit is 3. So initially the reverse is 0. So now what happens? The reverse is 0, that is multiplied by reverse equals reverse multiplied by 10 plus the digit, that is 3. So 0 multiplied by 10 will become 0. So the reverse will become 0 plus 3 is 3. So after that the last digit of x will be removed. So x will become 12. So the last digit will become 2. So if you reverse, the reverse value is currently 3. So 3 multiplied by 10 plus 2. So here the reverse value is 30 plus 2, it is 32. So next the x will become 1 and last digit is 1. So the reverse is 32 multiplied by 10 plus 1. So the reverse value will become 320 plus 1. So it will become 321. So the x will become 0. So the loop will stop. So we got the value 321 when we reverse 123. So next we have to check the overflow. So for that, after the while loop, if my reverse is less than the integer of minimum value, or my reverse is greater than the integer of maximum value. So if it is satisfies any one of this condition, I have to return 0 instead of the value. So return 0. So if not, it should be in the range that the integer can hold. So return, we have to convert this into integer because the return type is integer, but we are having long. So it will be explicitly converted into integer and it will be given to the function. So now we are checking that after the loop, the reverse hold the full reverse number as long as. So we check whether if it is fits within the 32-bit signed integer. So if it is out of the range, like it is less than the integer minimum and greater than the integer maximum. So if it is defined in this limit, so if the reverse is outside this range, we return the 0 as the problem specifies. So this is why we use long. So if reverse had been an int, it might have already overflowed during the loop, and checking after the fact would be meaningless. So long, let us safely accumulate the full reverse number and check cleanly. So after that, we have typecasting and returning the value. So we confirmed that if the reverse is within the range, so we just cast it into integer and return it. So the cast is safe here. So we just proved the value fits. Explicit casting also makes our integer clear and any reader. So first let us run it. So it is passed the test cases. So even if you didn't check this condition, so for example, if I comment this condition, okay, so if I run it again, still it passes. But if you submit it, it will check with multiple test cases. So that time it will become fail. So let me show you here that if I submit it without checking in the range, so it says, see here, only 1036 test cases are passed and nearly around more than 9 test cases are having been failed. So for that, we have to check with this overflow function. So this is where the most of the people, beginner would stuck here, that what did I do wrong, like that. So make sure you are checking with this condition. So now let us dry run. We have already dry run this program. So just analyze the complexity of this program. So for that, the while loop runs once per digit of x. So an integer has log base of 10x digits. So the time complexity is, I can say that time complexity is big O of log base 8. So for a 32-bit integer with at most 10 digits, that is at most 10 iterations. So essentially it is big O of n in practice. So but we'll use simply log n of x. So the space complexity is we only use two variables, that is digit and reverse. So that time it is in a constant space. There is no arrays, no strings, no recursions. So the constant space. So that time the space complexity is big O of 1. So let us see what are the common mistakes people would do. Before that, let us try to submit it with this condition being uncommented. So our solution is being accepted. So now let us write the solution in the LeetCode. So let us see the problem name. So it is reversing a integer. So LeetCode 7 an optimal approach with big O of log base x for the time complexity. So for the space complexity, it is big O of 1. So just change this value, big O of log base x, and if you come here, it is big O of 1. So now just post the solution here. So this is our solution. So now let us see what are the basic mistakes people would do here. So first is they will use integer instead of long for storing this reversing value. So if you declare reverse as int, the expression reverse multiplied by 10 and the adding digit will overflow during the loop because you even check and you ended up with the wrapped around garbage value that might accidentally pass the overflow check. So always use long to accumulate the reverse value for safety. So next one is people would convert it to string. So convert the integer to string and reverse the string and convert back to integer. So this works but doesn't teach you anything about numeric manipulation, handling negatives or overflow. So in an interview, examiner specifies want to see the digit extraction on approach. So don't take the string shortcut. Make sure to follow the match approach. So next one is they will forget the trailing zeros. So if x is ends with 0 like 120, so the reverse digits become leading zeros in reverse. So since we are building reverse numerically, so the leading zeros will automatically drop. So not instead of 0 2, if you reverse 20, so instead of reverse 0 2, the mathematically handle it and it will give the value 2. So don't just add special case code that might accidentally break this. So next one is not handling the value if x is 0. So while in this while loop condition, if x is not 0, so it is immediately false. So the reverse value is always 0 here. So it will directly return the value 0. So it will always handles this. So we return 0. So correct. But if you are writing for x greater than 0, so the negative inputs never enter the loop. So that's one of the bugs. So most of the people would give x greater than 0 like this instead of x not equal 0. So make sure you use x not equal 0 instead of x greater than 0. And this instead of using integer min and integer max, so the absolute value is -2147483. So it cannot be represented as the positive integer. So it overflows to the integer min itself. So if you try to do absolute value of this. So in 32-bit arithmetic, you get undefined behavior. So our digit extraction approach completely sides up this because of we never take the absolute value. So the sign flows through the naturally. So this LeetCode 7 teaches you the dependency program with numbers. So three things you have to take away, that is modulo and division to extract the digits and never convert to string. So use modulo after the loop using integer min and max. So the time complexity is big O of log x and space complexity is big O of 1. So the problem is discipline simply on tests whether you are actually understand this numeric boundaries. So make sure to follow along this videos and channel, because in the next week we are going to land on code forces problems. So we are going to make live sessions on code forces problem solving. So make sure to watch it. So if you like this video, put a like and subscribe and stay right there. So I have a big announcement that in this Infotechis communities, we are going to launch get into code forces as well. So make sure to follow along with this channel. So that's all for this